only got that, so I have to use the total values as well. So voltage total is 200, resistance total is 12.5, and then I like to use the Casio FX82AU Plus 2 awesome calculator. So I can go 200 divided by 12.5, and that gives me 16 amps. So you can see now I'm using those 3 steps from the ACSF to calculate this. I've identified what is important, I've selected my formula from here, and then I'm communicating it by underlining it and putting the units right next to it. So the next step is, I'm going to do it in blue, hopefully you can see it on there. Just move this slightly over. I'm going to calculate voltage. So if I go voltage equals I times R. So voltage equals I times R. But I want to calculate number 1, so I label it voltage 1, current 1, resistance 1. One thing that we need to realize or recognize here from this and from that is that these currents are all the same. So I can say that, this I total equals I1 and it equals I2, which equals 16 amps. Very important that I recognize that. So now I know that I1 is 16 times 5, and if I go 16 times 5 on my calculator, I can see that it is 80 volts. V2, let's look at V2. V2 equals I2 R2. I'll just move it slightly so you can see. Again, I2, we can see I2 down here is 16 times 7.5. I put it into my calculator, 16 times 7.5, and it gives me 120 volts. Now, I always say this, you need to check as you go along because it's very easy and you'd be silly not to. So remember in the beginning I said, if I move this over, voltage total here equals the V1, which is in this one, and V2 here. So if I make it in the same colors, you can see that I got voltage drop here and voltage drop 2 over there. So these two added together should equal that there. So let's test it. 80 plus the 120 equals 200 volts. So therefore I know that everything that I've done to here is correct. So now I've done, according to my steps and my rules, the total resistance, I've done the current, I've done the voltage drops. Now I need to do P. So I'm going to use green, hopefully it stands out. So I can say P1, so I can look at my formulas here. I can use whichever one. So I'll go for P equals VI. So P equals VI. But again, I can only use the quantities that are applicable to the resistor I want to calculate. In this case, I want to calculate what P1 would be. So I label it P1, V1, I1. So voltage 1 is, if I'm looking at my calculators, we're 80. The current we know stays the same, I1, 16 amps. So I go 80 times 16 and I will get 1280 watts. Okay, now let's do P2. V2, I2. Voltage 2 we can see is 120 times I2 is 16. So I go 120 times 16 equals 1920 watts. Again, I can test this. So the total here would be 1280 plus 1920 and that equals 3,200 watts. See? Alright. Now, how do I test it? I can test it by using the same formula I used before. P equals VI. But this time, I'm going to use the total values. So we know that voltage total is 200. The total current is 16. And if I put that into my calculator, you will see that it equals 3,200 watts. That means everything that I've done to here is correct. So this gives you an idea of how to do it. I'm hoping that this video will help, and have a look at my parallel circuit, my series parallel circuit and transposing videos as well if you're having any issues with this.